Okay, Clemence, what ideas do you have?
I want to make an IRL sewing machine.
Interesting.
That was actually going to be my 258 project.
Oh, really?
Yeah, but then it was too much work. You have to get the mechanical stuff.
Yeah, you have to buy a lot of your own parts.
I have some parts.
Oh, it'd be interesting to do that with a neural Turing machine.
The fuck is a neural turn? Oh yeah, I know.
It's like a Turing machine, but with like neural nets.
The fuck?
It's not a real Turing machine.
Yeah, how does that work?
Like it sort of behaves like a Turing machine.
Why do they call it a Turing machine? Did they even prove anything about its expressive ability?
I'm pretty sure they did. Like I thought that was the idea.
It couldn't even sort two numbers correctly. I mean, a couple okay, two numbers, yes.
They can sort numbers.
It couldn't sort like multiple numbers.
Yeah, how many numbers can it sort?
Let me search it up. Let me search it up. Let me search it up.
Fuzzy pattern matching?
All right. Foundational research. Bunch of.
Is this like an actual, this is not a computation model, right?
They don't have any proofs. It's just.
No proofs.
Hold
Just
on, wait. I swear I
just
remember
proof of
I heard
concepts.
something about this. Let me search it up. Okay, neural Turing machine.
You have
Let's see.
sorting.
It'd be pretty interesting actually. See if you can make neural Turing machines out of like biological neurons.
I don't understand what a neural Turing machine is.
Okay,
Neural Turing machines
it
are
is a
probably-
recurrent neural network.
Probably Turing. I'm pretty sure using recurrent neural networks, you can get that to like make it. It's Turing complete. I'm pretty sure.
Okay,
Neural
so
networks as like a paradigm.
so a neural Turing machine has a neural network controller coupled to external memory resources, which it interacts with through attentional mechanisms. Memory interactions are differentiable end-to-end, making it possible to optimize them with gradient descent. An NTM with a long short-term memory network controller can infer simple algorithms such as copying, sorting, and associative recall from input and output examples. They can infer algorithms for input and output examples alone. Huh. Interesting. So then you have differentiable neural computers, which is outputted by the same people. Oh, so then they can store and recall like binary numbers and things, and like, what else can they do? Oh, dude, okay, yeah. So, like, with the controller, it can have like an input gate vector, output gate vector, for gate vector, or whatever. And then in terms of like, so it can read and write things, it can erase things, it can, let's see, what else can it do? Oh, so it can look up stuff. It can, okay, this is now over my head.
Yeah. For every Turing machine, there is a recurrent neural network.
Ooh, where does it say this?
The claim.
Claim.
Yeah, but how do you get infinite memory out of that? How would you
Just
get?
have a lot of them.
There's no way to generate like memory.
Pretty much, there's no way to generate memory.
No, how would you? A Turing machine needs infinite memory.
Is it?
Yes.
Yeah.
It's infinite.
Right. So how does that even work?
Wait, if what is infinite?
The tape is infinite.
Oh, that's fair.
A Turing machine with like finite memory, I'm pretty sure is. What would that be?
Well, you can show that.
It wouldn't be as strong. It wouldn't be as strong as like an FSM, right?
You can show that some train machines only use only use but
That is interesting, actually. That is a good point.
RNNs are probably not practically Turing complete. That is true.
Are these like feasible or like practical?
It's super theoretical.
Yeah.
Yeah.
What would be like their use case for them?
I think it's literally just to like show that you can use neural nets to do like programming that we generally do like on a computer, like as a list of instructions.
Oh, interesting.
Yeah.
Not only that, it kind of provides a really rough upper bound of what exactly neural nets are capable of.
Yeah,
Huh.
that is fair.
Interesting.
That is fair.
I'm actually gonna die. I'm actually gonna die.
Oh.
Cool.
Do you want
Okay.
to-
And wait, how are you tying that into an idea?
Huh?
How are you tying these Turing machines to an idea?
Oh no, like, can you make a neural Turing machine with like biological neurons?
Can you even make a neural chain machine? Like, is that a thing that exists?
Yes.
Well, yeah. It was a paper by Alex Graves et al. In 2014.
I'm pretty sure recurrent neural networks are
Look up
kind of
Look up differentiable neural computers. Those are kind of interesting, because they seem to have a lot of like the similar. They seem to have a lot of like similar. What do you call it? Like operations that your typical CPU does. Like in terms of like read, write, store, erase, stuff like that. And then like they also have sort. They have lookup. Yeah, so like yeah. That'd be interesting. Oh, hold on. Okay, yeah, I think this is like, yo, Jack, you're gonna have to save me here.
What about it?
Huh?
Yeah,
Search up differentiable neural computers and tell me if you understand the Wikipedia fully.
Go ahead, Jack.
Yeah, Jack, you'll flex your math skills.
What the fuck is auto-associated memory?
Let's click that. A type of memory that enables one to retrieve a piece of data from only a tiny sample of itself. Oh, that's cool.
See this, Kumos? See this? This is trivial, right?
Okay, so we are looking at this right now. It's a list of operations that a differentiable neural computer can do, and we're trying to understand what
Oh
it
my
says.
god.
I'm not. I'm trying
Chill.
to understand neural network.
Wait, what are you trying to understand?
I'm trying to understand what this means. This question is asking me for.
Oh, true.
Studying for exams as well.
Yeah.
Huh.
Oh, Jack, you should explain orthogonality.
No.
It'll help you prepare your
That's
exam.
deep.
Orthogonal.
What? Cool. Okay.
Alright.
Wait, Matt, do you have any ideas?
Do I have an idea? I think I've exhausted all mine in the previous weeks. Although I was reading an article about businesses now starting to use EEG to help make business decisions. So what they do, so like I think IKEA started doing this, as in they they propose transformative business model, new business models to, let's say, clients, and then they record their EEG data, and then from that they can determine if they have good reaction or bad reaction to which specific transformative big idea.
Yo, that's crazy.
So I'm not exactly sure how.
So they're doing like neuromarketing, but on like consulting ideas.
Yeah, so it kind of replaces the consultant, I guess. Not exactly, but I'm not exactly sure how feasible it is anyways. I'd
No,
read.
because neuromarketing is a very, it's not that established, but like there is a lot of like, like there's a lot of stuff being done in neuromarketing. So like, for example, you have like Procter and Gamble, I
Yeah.
think, like they came to like one of our like conferences, and they were talking about like how they've like done a bunch of neuromarketing. Plus you have
Okay.
neuromarketing firms, but those are usually used for consumer applications. So like,
Yeah.
whether advertising is gonna appeal
Ah,
well
I
to
see.
a consumer or something
Yeah.
like that. But it's actually interesting that they're doing it for consulting.
Yeah, I guess they're applying the same concept,
Yeah.
but to business ideas,
Yeah.
much bigger
Does
scope, I guess.
does IKEA do it on their own execs, or do they do it on their investors, or do they do it like
Not
for
sure.
consulting?
I just read clients,
Yeah.
so I feel like stakeholders, probably their investors,
Yeah.
and then see, yeah, which idea got the best reaction.
Interesting.
Yeah.
That's
Um,
cool.
How do you watch this?
That's actually interesting.
hmm.
Cool.
Yeah.
Okay.
I think
I guess that's a wrap, or?
yeah, I think
Cool.
that sums up our idea generation sessions. It was basically a discussion of I think Turing machines, which I don't really know much about.
I
But
don't think
alright.
any of us know much about neural Turing machines.
But yeah, we'll be back for the summer.